Okay. Okay. So I welcome you to the last and final TS session in this course, Principles of Signals and Systems, offered by Professor Aditya Jagannathan from IIT Kanpur. And this is really the final TS session where the main aim is to go over the entire course from a bird's eye viewpoint, and we'll also be solving some questions from all the topics that we have seen in the last 12 weeks, specifically focusing on previous year questions from previous year gate examinations. Okay, so before we do that, a bit about myself. My name is Yashvanth, and I'm presently a PhD student at the Department of ECE IISc Bangalore. My research interests lie in signal processing and applications to wireless communication systems. You can write to me at this email ID if you have any queries about the TA sessions that we have had. And yeah, you can know more about me from this web link here. Okay, so the topics, as I told, that are going to be covered for this week, or in particular for today, is going to be a quick summary of the entire course, and also some problems solving session on previous year gate problems. Okay, so the first part, the summary of the course. Okay, so we started this course with what is known as a signal. So what we told that a signal is essentially a function that conveys some useful information about some phenomena, right? For example, it's just mathematically, it's just as good as any other function. For example, in particular, we talk about, at least at the basic levels of signal systems course, we talk about signal as a function of being time, whereas it need not be a function of time. It could be a function of space, it could be a function of frequency, or any other indexing set. Okay, for a most beginners course, we will talk about signals a function of time. Okay, so for example, x of t that maps a set of all real numbers to some number, let's say real number, because time could be any number, and it maps the input real number to a set from a closed interval minus 1 to 1. So this is an example of a signal, right? For example, x of t equal to sine t. So t could be any number, but no matter what t is, sine t is always between minus 1 and plus 1, right? So that's a particular signal. So that's what is written here. Okay, so t can range from any real number, but your x of t is bounded between minus 1 and plus 1. So in particular, it should be a useful information. It's not just sine t we took because for the sake that we are considering any arbitrary signal, but that should be a signal. It should be a function that conveys some useful information, because after all, we are engineers and we need to characterize some useful information. Okay, so there are two types of signals you can classify based on the time, the nature of the time. One is called the continuous time signal, where essentially the signal, the input to the signal time is a continuous number. Okay, it takes values in a continuous range. The other is called the discrete time signal, where you don't have continuous values for t. You can only take some discrete values. For example, x of 1, x of 2, and so on till x of 10, right? Or it can only take numbers in some integer domain. That's called a discrete time signal. So this is a classification based on time domain. Now you can also classify this based on the amplitude domain, where the first signal is called the analog signal. That is the amplitude x of t takes any continuous number, or digital signal where x of t takes only from a discrete set. X of t is not sine t, but let's say some other fraction, some other, let's say, Ceil function of sine t. That means x of t can only take values between minus 1, 0, and 1. It can only take one of these three values, because a Ceil function will only return an integer value. Right, regardless of what sine t is, you will only take the greatest integer, that is just, sorry, the lowest integer that is just above greater than sine t. Right, so that's because that means x of t can take only values between minus 1, 0, and 1. So x of t is equal to a Ceil function of sine t is essentially a digital signal, because it cannot take any value. It can only take between three values. So this is an example of amplitude being discrete in nature. Now, what is an even signal? An even signal is such a signal where x of minus t equals x of t. And what is odd signal? Odd signal is such a signal where x of minus t is equal to minus x of t. Okay. What is a periodic signal? Periodic signal, as a signal is said to be periodic if x of t plus capital T equals x of t. That is, the signal value, the amplitude will repeat itself after a capital T number of seconds. So in this context, capital T is called the period of the signal, and 1 over period is called the frequency of the signal. Okay. Now, what is an energy signal? Energy signal is nothing but you compute this, compute the expression integral minus infinity to plus infinity mod of x of t square dt. If this number turns out to be strictly a finite number, that is, it is less than infinity, then such a signal is said to be an energy signal. And in fact, this number that you're computing, this integral, is called the energy of the signal. That means it says that if the energy of the signal is a finite number, then essentially it is called an energy signal. Now, what is a power signal? So same, just like how energy should be finite, for a power signal, the power of the signal should be finite. If that is the case, then such signal is also called as a power signal. And a power is essentially computed as limit capital T tends to infinity, 1 by t integral minus t by 2 to plus t by 2 mod x of t square is less mod x of t square. This is called the power. If this power is less than infinity, that is a finite number, then it's a power signal. So these are the broad classifications of signals. We had also seen what is the power of an energy signal, what is the energy of a power signal. For example, if you compute the energy of a power signal, it turns out to be infinity. Similarly, if you compute the power of an energy signal, it turns out to be zero. There are such nuances which we studied, but I'm not summarizing them because I'm not telling all of them because it's only a high level description of the course today. Now, what is a system? A system is something that processes. A system is something that processes an input and outputs some desired signal. Okay, and what signal does it output depends on what the system is doing to your input signal. Okay, so mathematically, what it says is, okay, you take x of t, pass it through some system, you get y of t. This is such a processing is called. Such a processing is also called signal processing, and that is processed by what is called a system. So what is a memoryless system? A memoryless system is a system where the output depends only on the current input. It doesn't depend on past input or it doesn't depend on future input. Such a system is called memoryless system. Causal system. What is a causal system? For a causal system, the output only will not depend on the future input. That is, it will only depend on the current input or the past input. You are allowed for the output to depend on past input and present input, but not on future input. Okay, such a type of system is called a causal system. Now, what is stable system? If you give a bounded input, that is, if your input signal is bounded by some number, let's say mod of x of t is less than capital B, then mod y of t should be less than some other number b dash. B and b dash need not be equal, but it should be bounded. Okay, so if that a system obeys that property, that is, if the system gives a bounded output for a bounded input, then such a system is said to be stable in BIBO sense. That is, it's a BIBO stable system. That is a bounded input, bounded output stable system. Okay. Now, what's a linear system? A linear system is a system which obeys superposition principle. That is, what is superposition principle? It basically satisfies two properties. Okay. Let's say x1 of t, if you pass the input, it gives y1 of t as the output. Let's say you pass x2 of t as the input and you get y2 of t as the output. Okay, then superposition principle means it has to satisfy two properties. The first property is, suppose if I pass the sum of inputs x1 of t plus x2 of t as the input to the system, then the output must be y1 of t plus y2 of t. That is, the sum of the inputs should be sum of the outputs. Okay. That is, in other words, what I'm saying is the output of the sum of the inputs should be nothing but the sum of the outputs of the individual signals. Okay, if that is the case, then this system, the first property will be satisfied. The second property says that if you scale your signal x of t by a and pass that as an input, then the output should also get scaled by the same amount a. So if a times x of t is given as the input, then a times y of t should be the output, and this should hold for any value of scaling factor a. If these two properties are satisfied by any system, then that system is said to obey the superposition principle, and so it is a linear system. Now, what is time invariant system? Basically, what it says is, suppose if x of t gives output y of t, then any time shifted version of the input, let's say x of t minus tau, where tau is the time delayed version, right, or time shifted version, then that should give the output y of t minus tau. Okay, that is the same time scale, time shifting should be applied to the output also. If that is there, then that system is said to be time invariant. Note that this should hold for any value of shift tau. Okay. So in general, what happens is that naturally occurring systems, you can always, most of the naturally occurring systems can be classified under the broad notion of what is called linear time invariant system. Okay, that, or in short, LTI. Now, what is special about an LTI system? An LTI system has the unique notion of being characterized by what is called the impulse response. So these are some very special systems for which you can completely characterize the behavior of those systems. That is, if I give, let's say I give for any kind of input that I can give to the system, you can predict what will be the output even without measuring, passing that as a signal as input and measuring that output. Okay, just because you can characterize any LTI system using the impulse response. Okay, why is impulse response unique, special? That's because you can show that for any LTI system, the output of the LTI system is given by the convolution. Okay, it's a linear, it's called the convolution of the input and the input signal and the impulse response of the system. So there's convolve both the signals, and whatever is the signal you get, that's going to be the output of the LTI system. Okay, so that's basically about signals and systems, about from the first two lectures, or maybe perhaps three lectures. Next, we jump on to transforms. Okay, then we start in the course, we started the first transform that we studied in this course is what is called the Laplace transform. So Laplace transform is basically computed for a continuous time domain signal. So how is Laplace transform defined? It is defined as x of s, defined as integral minus infinity to plus infinity x of t e power minus st dt. Okay, and now say essentially this is an integration you're performing over infinite limits. So it's possible that this integral might not converge, right? So basically that brings us to the notion of what is called region of convergence. That is wherever this integral x of s converges. It's called the region of convergence. And now there are various properties of Laplace transform, like what? Time shifting property, frequency shifting property, convolution property, differentiation property, integral property. There are duality property. There are so many property, maybe not duality, but there are so many properties of Laplace transform. You can refer the notes, okay, to look at the properties of Laplace transform. Now, using Laplace transform, you can define what is called a transfer function of a given continuous time system. So what is transfer function? Essentially, what we know from the basics of LTI system is if this is a h of t is an impulse response of an LTI system, then the output y of t is nothing but the convolution of x of t and h of t. That's what I've written here. Okay, now by convolution property of the Laplace transform, if I take Laplace transform on both sides, then this is same as saying the product of x of s and h of s equals y of s. And now what you do, you define y of s divided by x of s, which is nothing but h of s. Now, this h of s is called the transfer function of the system. That is, the Laplace transform of the impulse response is basically called the transfer function of the continuous time system. Okay, so now while Laplace transform was defined for a continuous time signals and system, for the corresponding counterpart for a discrete time signals and system is what is called the Z transform. And Z transform has the following definition. That is, x of z is defined as summation over n equals minus infinity to plus infinity x of n z power minus n. So note that it is exactly like Laplace transform in the following sense. Big only difference is it is for a discrete time domain. So in Laplace transform, you see the parallel. For Laplace transform, you had integral minus infinity to plus infinity, but now that became summation over minus infinity to plus infinity. That's because when you go to discrete domain, you can only do sum. You cannot integrate. Similarly, x of t became x of n, and e power minus st becomes z power minus n. It is somewhat still exponential only. Okay, so so it basically mirrors like the definition of the Laplace transform. So that's why Z transform is also the equivalent counterpart of the Laplace transform, but in the discrete time domain. Similar to Laplace transform, you can also have a region of convergence for Z transform. That is the region over which this infinite summation x of z converges. Okay, again you can see the notes for the properties of Z transform. Similar to Laplace transform, you can define what is called a system function for a discrete time system, that is, which takes x of n as the input, a discrete time signal as an input, and let h of n be the impulse response of a discrete time LTI system, let y of n be the discrete time output. Okay, then the z transform of your impulse response, which is also given by the ratio of the z transform of the output to the z transform of the input, is called the system function of a given discrete time system. Okay, so that basically finishes the story for Laplace transform and Z transform. Now we delve into the special, very famous notion called the Fourier series. It is special because it is defined for a particular class of signals which are continuous time and periodic. Okay, only for continuous time periodic signals you define what is called the Fourier series. And how is it defined? So what it says is that any continuous time periodic signal x of t can be written as an infinite summation of mind from k equals minus infinity to plus infinity ck e power j 2 pi k f naught t. What is f naught? F naught is a fundamental frequency because it's a periodic signal, so you can have its fundamental frequency. What is fundamental frequency? 1 by t naught, where t naught is the fundamental period. The smallest period, smallest time for which x of t plus t equals x of t. The smallest value of capital T for which this equation holds is called the fundamental period. The inverse, the reciprocal of fundamental period is called the fundamental frequency. Okay, so this is what is called this is called the complex exponential CE, complex exponential Fourier series. Okay, you can find the value for CK. If I am not wrong, what CK says is that you can write CK as 1 by t integration over one time period x of t e power minus j 2 pi k f naught t dt. Okay, this was your expression for CK. Okay, so that is complex exponential Fourier series. You have another equivalent notion of what is called the trigonometric Fourier series, where what it says is that any continuous time periodic signal can be represented as summation of three terms. The first term is some constant independent of time, so it's basically like a DC term, which doesn't depend on any frequency. This frequency independent, the frequency component is 0, so it is a naught by 2, plus sum over plus summation, again infinite summation of ak cos 2 pi k f naught t, plus the third term again is an infinite summation, but with respect to bk and sine 2 pi k f naught t. So basically what it says is that you can decompose a continuous time periodic signal into three components. One is a frequency independent term, the second is basically an infinite summation of cos signals, and third is an infinite summation of sine signals. Okay, this is what is called a trigonometric Fourier series, and you have the similar expressions for a naught, ak, and bk. You have similar expressions like how you had for ck, and and we also saw that there is a relation between all ck's and ak's. It's not that they are completely independent. If someone gives you the value for ck, you can uniquely write down what is a naught, ak, and bk. That means if someone gives you the complex exponential Fourier series, you can write down its trigonometric Fourier series, and vice versa. If someone gives you the value for a naught, ak, and bk, and also someone gives you the trigonometric Fourier series, you can always write down the equivalent ck and construct the complex exponential Fourier series. Again, you see the notes for properties of Fourier series. And next, we generalize the notion of Fourier series to what is called a Fourier transform, which is defined even for continuous time aperiodic signals. Okay, not necessarily only for periodic signals. Of course, it is defined even for periodic. You can always write down the Fourier transform of a periodic signal. If you recall, what we did is that any periodic signal can be represented as a Fourier series. So now just take Fourier transform on both sides. Okay, and what did we see? We saw that by time shifting property, Fourier transform of a complex exponential is nothing but a delta function, a impulse function. So essentially, the Fourier transform of any periodic signal is going to be an impulse train with amplitude depending on the value of ck. Okay, that is something we had solved in one of our classes sessions. Find the Fourier transform of a continuous time periodic signal. In fact, we solve it using Fourier series only. So how is Fourier transform defined? It's defined as x of omega, defined as integral minus infinity to plus infinity x of t e power minus j omega t dt. Okay, so in other words, what is the inverse Fourier transform? That is given x of omega, how to recover by x of t. That is also there, integral minus infinity to plus infinity x of omega e power plus j omega t d omega and multiply by 2, 1 by 2 pi. Okay, by the way, just like how we have inverse Fourier transform, we also have inverse Z transform and inverse Laplace transform. Of course, if you remember, by partial fraction, we saw different methods for Z transform, partial fraction method, complete long division method, and I think complex integration method. There are three methods. Similarly, for Laplace transform also, you have some methods. Like most commonly used method is by partial fraction method. Okay, and now basically again look at the notes for properties of Fourier transform, and now there is a relation between the Laplace transform and the Fourier transform. When you evaluate the Laplace transform at s equal to j omega, that gives you the Fourier transform. Of course, with one small caveat, that is the ROC of Laplace transform should include unit circle. If this happens, then you evaluate the Laplace transform at put s is equal to j omega, that will give you the Fourier transform. So that's the trick to obtain the Fourier transform from the Laplace transform. So if given a Fourier transform, we also saw what is the frequency response of a system. Essentially, it is nothing but you take x of t as the input and you get y of t as the output. Let's say h of t is the impulse response of the given LTI system. Then the frequency response of this continuous time LTI system is nothing but the ratio of the frequency, the Fourier transform of the output to the Fourier transform of the input. Okay, and we also saw that e power j omega t is called the eigenfunction of an LTI system. That's because if I pass e power j omega naught t as the input to any LTI system, the output will be scaled version lambda times e power j omega naught t, where lambda is some scalar. So essentially output is some scaled version of the input, so it's called an eigenfunction of an LTI system. And what is distortionless response? It says that the output of the system can be at most scaled and time shifted version. It should not have any other operation. As long as this is satisfied, then that system which does this operation is said to produce a distortionless response of the signal. And then we went on to study what is called a filter. A filter is nothing but an LTI system that will only allow specific frequency components to be passed in the output from the input. So for example, low pass filter means you only want the low frequency components to be passed from the input to output. Let's say, for example, let's say the input signal x of t has a frequency content from 5 hertz to 50 hertz. Okay, now if I use a low pass filter of, let's say, 10 hertz, then what happens is the output, the content will be only from 5 hertz to 10 hertz. Okay, that's called a low pass filter. Okay, so that's basically called the low pass filter. That is, it doesn't allow. So okay, let me just, it went away. So let's say the x of t had the content 5 hertz to 50 hertz. Okay, let's say that is an example. And there, let's say you want to use a low pass filter, okay, which will only allow, or maybe cutoff frequency, you should just say fc equal to 10 hertz. Okay, then what it means is y of t will only have the frequency content from 5 hertz to 10 hertz. It will not allow any frequency component from 10 to 50 hertz. Okay, that such type of systems or such type of filter is called a low pass filter. Okay. Yeah, actually someone joined newly. Can you please unmute yourself? Because it's creating some noise. Okay, let me try to unmute. Mute. Let me try to mute you. Okay, I have muted the participant. I think the participant's name is Kasi, so please be muted unless you have some question to ask. That's called. Okay, again they have unmuted. Now there is a participant named Kasi, or I don't know if I'm pronouncing the name correctly. Can you please mute yourself because it's creating some noise? Okay. Okay, so let's continue. So That is called a low pass filter. Now high pass filter means, let's say if I use high pass filter, then what happens is all the frequency from 10 hertz to 50 hertz will be passed, but 5 to 10 will not be passed. That's called a high pass filter. Similarly, if you want some specific range of frequencies to be passed, then that is called band pass filter. Similarly, your specific range to be not to be passed with the output, that's called a band stop filter. So next we saw what is called the sampling operation, very important operation. Okay, what sampling operation does is it will obtain a discrete time signal from a given continuous time signal. Okay, so that is the process of obtaining a discrete time signal from continuous signal is what is called sampling. And you can show that the Fourier transform of a sampled signal is the periodic version of the Fourier transform of the unsampled signal. And what is the period of the periodic version? Equal to sampling frequency. Okay, what I mean by this is, let's say the unsampled version Fourier spectrum was like this. When you sample the signal, the spectrum will repeat. And what is the period with which it repeats? Exactly equal to sampling frequency with which you sampled your continuous time domain signal. Okay, now very important theorem, very important result in sampling theory is what is called the Nyquist sampling theorem, or it gives what is called Nyquist sampling rate. So what it says is any signal can be uniquely reconstructed from its sampled signal without any distortion if the sampling frequency is at least 2 times the maximum frequency content F max. Okay, if I put equality, then Fs equal to 2 F max is, then this sampling frequency is called the Nyquist rate. If you can sample at more than Nyquist rate also, it says at least you should sample at the Nyquist rate, which is 2 times the maximum frequency content in the given signal x of t. Okay, so now then what we saw is discrete Fourier series. Just like how Fourier series was studied for a continuous time periodic signal, discrete Fourier series studied for a discrete time periodic signal. What it says is that any discrete time periodic signal x of n can be represented as a finite summation. This is the main difference. For a Fourier series you had infinite summation, but for a discrete Fourier series you have only finite summation. Okay, ck e power j k 2 pi by n naught times n, where n naught is the fundamental period of your discrete time periodic signal. And you can see notes for the properties of discrete Fourier series. Then we studied what is called the discrete time Fourier transform, which basically which is also like the Fourier transform, but for now this is for a discrete time signal. So unlike the discrete Fourier series, which was only for a discrete time periodic signal, a discrete time Fourier transform can be applied even for discrete time aperiodic signal. Okay, so it is how is it defined? It is defined as x of omega equal to an infinite summation x of n e power minus j omega n. So omega is the discrete frequency. And similarly you can define what is called the inverse discrete time Fourier transform, which is basically having a similar expression like how every other inverse transform had. Again, look at the notes for the properties of DTFT. And as a result, you can characterize the frequency response of a discrete time signal now. So what basically it says is you take the frequency response of a discrete time signal is given by the DTFT of the impulse response, which is a ratio of the DT of T of the output to the DTFT of the input. Okay. And the last important but not the least important topic of the course was discrete Fourier transform, which basically is used for a finite timeline sequence. So the main difference between the discrete Fourier transform or discrete time Fourier transform is that in discrete time Fourier transform, the time domain is discrete, but the frequency domain is continuous. But in discrete Fourier transform, both time and frequency domain both are discrete in nature. That is the main difference. Okay, the frequency domain signal is also discrete in discrete Fourier transform. So how is it discrete Fourier transform defined as x of k equal to summation, again a finite summation from n equal to 0 to n minus 1, x of n e power minus j 2 pi by capital N times kn, where k ranges from 0 to n minus 1. So you see this k is a frequency domain variable which only takes finite discrete number of values 0 to n minus 1. Similarly, you can find, if we're given a DFT, you can find what DFT signal x of k. You can recover back the time domain signal x of n through this inverse relation. Excuse me. So you can obtain the DFT from the DTFT by sampling the DTFT, the frequency domain signal, at omega equal to 2 pi by capital N times k. So basically DTFT and DFT has a relation. Again, you look at the properties of DFT. Okay, and I think the last lecture we saw these terms of what is called the phase delay. Phase delay is defined as the minus the omega. Let's say, okay, maybe let me write it down. Phi of omega is nothing but the phase response of the system, or phase spectrum, because it's a function of frequency. Phase spectrum of system. Then tau p of omega is called the phase delay, which is defined as minus phi of omega naught by omega naught. That is the delay in the carrier input. Similarly, what is group delay? Group delay is denoted by tau g of omega naught, which is nothing but the negative derivative of the phase response with respect to omega computed at omega equals omega naught. So this has the interpretation that what is the delay in the message signal when you pass it through the system. Okay, and the last thing we saw is a realization of what is called the IIR filter, and we saw that you can realize it through different forms: direct forms 1, 2, transpose forms, cascaded forms, parallel forms 1 and 2. So I guess I've covered pretty much all topics that we have seen in this course in the last 12 weeks. I guess this is the right time to ask for any doubts that you have in the entire course. Are there any doubts? Yes. Are there any doubts? Is everything clear? I've pretty much covered every single topic that we have seen in the last um, 12 weeks. Okay, so one student says no doubt. The other student, if you have doubt, you can please, this is the right time to ask. Okay, I don't see any doubt, so let's move on. Great. So the second part of this today's session is going to be on GATE problem solving session. So what I've done is I've picked up some previous year GATE questions from this signals and systems topic, and let's solve some of these questions. Okay. The first question is as follows. So the question goes as follows: in what range should real part of S remain so that the Laplace transform of the function x of t equal to e power a plus 2t plus 5 into unit sub function u of t exists? Essentially, what it's asking is, if I compute the Laplace transform of x of t, what should be the range of real part of S so that this integral, this Laplace transform exists? What is it asking? Essentially, what is the region of convergence? That's all. That's the question. Is it clear? If you find the region of convergence, that is the answer to this question. Is that clear? First of all, is that clear? Yeah, great. That's all. There's nothing. How did you find region of conversion? Region of convergence, let's go by definition of Laplace transform. We know that x of s is given by, okay, here it's okay, x of s is given by integral minus infinity to plus infinity x of t e power minus st dt. But now I've made it 0 to infinity. Can anyone tell me why I did not consider minus infinity to plus infinity? Or maybe here it's not correct to say 0. Maybe here it's minus infinity. The next step I have made 0 to infinity. Can you now tell? Yeah, exactly. You gave the right answer because of unit sub function. Anyways, u of t is 0 for t less than 0. Therefore, it is enough if you compute the integral from 0 to infinity, in which case u of t is just equal to 1. So I just need to integrate e power a plus 2t plus 5. That's what I'm writing. So integral 0 to infinity e power a plus 2 times t plus 5 into e power minus st dt. Now e power 5 is constant, so take it out. So it's basically integral e power minus s minus a minus 2. So I took minus common. So this minus s is the first term. A plus 2 comes as plus. So when I take minus common, I do an additional minus. Okay. So that's basically, this is your integral. Now you integrate it. What is the integral value? That's integrate e power x dx, right? Or e power ax dx, nothing but e power ax by ax. Oh, sorry, by a. That's what I write. E power 5 by a plus 2 minus s into e power minus s minus a minus 2, limits 0 to infinity. Now, if I put that limit to 0 to infinity, what I should do? This is how it goes. E power 0 is anyways 1, so that's nothing in unboundedness about the second term. Now look at the first term. In the first term, I have to put t equal to infinity, right? I have to put t equal to infinity. Now, what happens? So that's what this infinity is for t. Now you see, if the argument before infinity, this s minus a minus 2, this has to be positive. Why? Because only then this is like e power minus c infinity, where c is a positive number. Only then this will go to 0. Suppose c were negative, let's say minus 5. Then minus of minus 5 is pi. So e power plus pi infinity is going to be going to infinity. I want it to be some e power minus infinity form, right? It has to be negative. Only then this will go to 0. So that the entire the entire integral value will be a finite number. If it is going to be this s minus a minus 2, if it's going to be a negative number, then that will cancel the minus. So the first term will be effectively something like e power infinity, which will make it go to infinity. Then you cannot make this number to be less than infinity, a finite number. That means the integral does not converge in that region. Therefore, for convergence, you need s minus a minus 2 to be positive. Okay, or in other words, real part of s minus a minus 2 should be positive, or real part of s must be greater than a plus 2. Go back to the equation, so given options, that is the first option. Real part of s must be greater than a plus 2. So it's option A. Okay, so this was a question from GATE 2005. Is it clear? Okay. The next question is as follows. A continuous time LTI system is described by this constant coefficient, what is it called? Differential equation. Linear constant coefficient differential equation. Okay? An LTI system. This is the differential equation. The question is, assume that you have zero initial condition. Okay, then the response y of t of the above system for the input x of t equal to e power minus 2t u of t is given by. That is, what it says is, let's say the LTI system is described by this differential equation. If I give x of t equal to e power minus 2t u of t as the input, what is the output y of t? That is what is the question. This is a question asked in GATE 2010. So let's go to the solution. Again, very simple. So first of all, what you need to do? To find the output, you need to convolve x of t and h of t, impulse response. But you're not given the impulse response. Rather, you have given the constant coefficient differential equation. From this, you can infer the transfer function. Okay, that's what we're going to do first. So this was your differential equation. What we will do now is we'll take Laplace transform on both sides. So recall, by differentiation property, if you differentiate your y of t 2 times, that is means the Laplace domain you will multiply s 2 times to y of s. So that means second order differentiation of y of t will have the Laplace transform s squared times y of s. Is that clear? First of all, is this clear? Do you remember this just by using the differentiation property of Laplace transform? Is it clear? Yeah, correct. So now I want to remind you one thing. You can go back and check. This is a homework. Suppose if they did in the question they did not tell you zero initial condition. Let's say they gave you non-zero initial condition, then this is just not correct. You need to subtract with something called y0 minus. Okay, so that is the second order differentiation is given by s square of y of s minus two terms will be there. I forgot the two terms which will depend on y0 minus. That is what was the response of the system at initial condition at zero input. Without even giving input, the system will have some initial output. Okay, that is called the initial condition. In the given question, they have told zero initial condition. Therefore, both y of 0 minus will go to 0. Okay, but if it is not 0, then there is a different, slightly a different expression for the Laplace transform of second order derivative. I think it's given in Oppenheim book. Please check it out. Okay, but now don't worry, it is zero initial condition. So the second order derivative is just will have the Laplace transform s square times y of s. Similarly, 4 times dy by dt will have the Laplace transform 4 times s times y of s, and 3y of t will have the Laplace transform 3 times y of s, equal to 2 times d by dt of xt, that is nothing but 2 into s times x of s, plus 4x of t will become 4x of s. Now rearrange everything, take y of s common, it becomes s square plus 4s plus 3 times y of s equal to 2s plus 4 times x of s. Now what we know is that transfer function is given by the ratio of output to input. So output Laplace transform to input Laplace transform. So basically what you do, bring this x of s denoted to the left hand side and this s square plus 4s plus 3 to the right hand side. So what you get is y of s by x of s equals 2s plus 4 divided by s square plus 4s plus 3, which is nothing but the transfer function h of s. So we found out the transfer function. Okay, now what should I do? I I basically, if I were to do it properly, I have to now find the inverse Laplace transform of x of h of s to find the impulse response and convolve that with x of t. Right, and convolution is a tedious operation. You need to look out for different range of intervals and so on and so forth. And in rather a easy way to perform convolution is go back to the Laplace domain and do multiplication. Use the convolution property, and already we have the Laplace transform of impulse response. So you don't need to find the impulse response. Just stick with the Laplace domain. What you do, you take the Laplace transform of the input. So input is given to be x of t is equal to e power minus 2t into u of t. Therefore, its Laplace transform is nothing but, you can show this is nothing but, so e power minus at u of t has a Laplace transform 1 by s plus a. So here a is nothing but 2, so therefore x of s is nothing but 1 by s plus 2. Therefore, by convolution property of Laplace transform, your output Laplace transform is nothing but h of s multiplied by x of s. And we know h of s from the first square, from the above part, so it's 2s plus 4 divided by s square plus 4s plus 3 times x of s. X of s is 1 by s plus 2. Now you see 2s plus 4 can be written as 2 times s plus 2. Right, you can factorize, but that x plus 2 and this s plus 2 will cancel out. Therefore, the only y of s is nothing but 2 divided by s square plus 4s plus 3. Okay, so now I know the Laplace transform of the output. Now I need to find the output itself in time domain. So all you need to do is take the inverse Laplace transform of y of s. How do I do? Go by partial fraction expansion. So I can represent y of s as that. So if you remember, the s square plus 4s plus 3 can be factorized as s plus 1 into s plus 3. Therefore, it has two poles. Both are simple poles at s equals minus 1 and s equal to minus 3. Therefore, you can factorize this as by partial fraction expansion as a by s plus 1 plus b by s plus 3. And we need to find the values of a and b, where a is nothing but take y of s, multiply by s plus 1 and evaluate at s equal to minus 1. So what happens is that y of s is nothing but 2 times s plus divided by s plus 1 into s plus 3, and when you multiply s plus 1 gets cancelled. So it's just 2 by s plus 3 and evaluate at s equals minus 1. So it becomes 2 divided by 3 minus 1, which is equal to 2 by 2 or 1. So a is equal to 1. Similarly, if you want to look at the expression for b is nothing but y of s into s plus 3 at s equal to minus 3. So what you do, that again s plus 3 and s plus 3 will get cancelled. So you will be left out with 2 by s plus 1 at s equal to minus 3. Therefore, what you get is 2 divided by minus 3 plus 1, which is nothing but 2 by minus 2, which is equal to minus 1. Therefore, your y of s is nothing but 1 by s plus 1. A became 1, right? So it becomes 1 by s plus 1, and b became minus 1. Therefore, minus 1 by s plus 3. Okay, so y of s is nothing but given by this. Now just invert both these terms separately. So 1 by s plus 1 has the inverse Laplace transform e power minus t into u of t, and 1 by s plus 3 has the Laplace transform e power minus 3t into u of t, and put a minus in between. Therefore, your output is nothing but e power minus t minus e power minus 3t whole into u of t. Let's go back to the options. We had a minus, right? Huh. Okay. So it is option B. Okay, is it clear? Okay, great. Now let's move on to the next question. The next question goes as follows. If the unit step response of a network is 1 minus e power minus alpha t, then what is its unit impulse response? Okay, that is what they are saying is you pass a unit step function as the input, then the response means output. Okay, the response means output. So if you pass unit step function as an input, then the output is given by 1 minus e power minus alpha t. For such a system, if I pass unit impulse response as the input, then what is its output? That's basically the question. And this was basically a question asked in GATE 2011. Okay, so that's what I'm mathematically writing down here. Let's say u of t, which is a unit step function. You are passing that as an input to some system whose impulse response is h of t. And the output, okay, y of t. I'm writing u of t to just denote that this is the output obtained when u of t is given as the input. Y of t for u of t as input is given as 1 minus e power minus alpha t. That is given in the question. Then basically what they're asking is what is h of t? Why? Because what they're asking, what is the unit impulse response? That is, what will be the output if you pass impulse as the input? That is nothing but the impulse response. The output for a unit impulse response is called the impulse response of LTE system. Therefore, they're essentially asking what is h of t. Okay. So what do we know? We know from the basics of LTE system that your y, the output when you pass unit step function as the input is given by the convolution of the unit step function and the impulse response h of t. Okay, and now take the Laplace transform on both sides because of convolution property. Now u of t, so y of s is equal to u of s into h of s. But u of s, I know the Laplace transform is 1 by s. That is, u of t has the Laplace transform 1 by s. Therefore, h of s is nothing but s into y of s. Okay. Now recall, what does this mean? If the Laplace transform is s times some signal, that means its inverse Laplace transform should be derivative of that signal. Derivative of the inverse Laplace transform of y of s. That is what is differentiation property of Laplace transform tells. Right? So if h of s is s times y of s, h of t should be d by dt of y of t. But I know y of t. What is y of t? E power minus given e power minus 1 minus e power minus alpha t. So just differentiate 1 minus e power minus alpha t with respect to t. The answer is alpha into e power minus alpha t. Okay, because of chain rule, 1 will go to 0 when you differentiate. There's a minus, but there's a minus coming from the exponent also. That minus will cancel out with that minus. So it's just alpha into e power minus alpha t. So which is nothing but option A. Is it clear? Okay, great. The next question goes as follows. It says that the impulse response of a system is given as h of t equal to t into u of t. Fine. Now the question is, if you pass input for input u of t minus 1, what is the output? This was also a GATE question from 2013. Okay, very simple again. They have given the impulse response, they have given the input, what is y of t. Just you need to perform convolution. But since convolution is difficult, again we'll go back to Laplace domain. Meaning we will multiply the Laplace transforms of both the input and of the impulse response. You will get the Laplace transform of output, then invert it back, invert the Laplace transform to time domain. That's the approach we're going to do here also. So the given question is h of t is equal to t into u of t, x of t is equal to u of t minus 1. So what is y of t? Okay, so again let's go with the Laplace domain approach. So if you take the Laplace transform of h of t, that is t into u of t is nothing but 1 by s square. Okay, Laplace transform of x of t, u of t minus 1 is nothing but e power minus s by s. That is, u of t had the Laplace transform 1 by s. So if you time shift it, it's basically time shifting property is nothing but e power minus s by s. Okay, the time shifting property of Laplace transform. By convolution property, what is y of s? Y of s is the product of h of s and x of s. X of s into h of s. X of s is nothing but e power minus s by s. H of s is 1 by s square. Therefore, your y of s is e power minus s by s cube. Now, see how did we obtain e power minus s by s cube? You can obtain e power minus s by s cube as first you take 1 by s cube and then you multiply it with e power minus s so that you get e power minus s by s cube. Okay, but what is the inverse Laplace transform of 1 by s cube? We, in fact, this is also a question we had solved in class. We solved for general 1 by s power n. In the one of our problems, we had solved for 1 by s power n. So therefore, it is put n equal to 3. You will get this. I think we showed that the inverse Laplace transform will be t n t power n minus 1 by n minus 1 factorial into u of n, something like that. Right? Now put n equal to 3. You get what? T square divided by 2 into u of t. We had proved this in the class for a general n. Now put n equal to 3 in that expression. Therefore, 1 by s cube will have the inverse Laplace transform t square by 2 into u of t. Therefore, e power minus s into s cube is nothing but a time shifted version of this t square by 2 into u of t. Therefore, the inverse Laplace transform of e power minus s by s cube is nothing but t minus 1 the whole square by 2 into u of t minus 1, which is nothing but option C. Is it clear? Okay. What we will do is we are exactly at 7 p.m. point. What we'll do is we'll take a 10-minute break or even 15-minute break to 7:15. Okay, and then we will again resume our session. What you do is you just be online. Don't leave the call. Just be online and take some rest. At 7:15, you will again resume solving the other questions. Is that okay? If you have doubts, you can ask me now in whatever we have solved, or any doubts in the questions that we solved today, or any of the other TA sessions that we have solved in the previous weeks. If you have any questions, please ask at the right time. Otherwise, we'll take a break and then again resume solving at 7:15. Okay, just exactly 15 minutes break from now. Okay, there is, before we begin, there is a question. Past sessions, I did not attend. How can I see? Yeah, I think NPTEL shares all the links with you, both the notes and my video lectures. Or otherwise, you can also, I also upload all my videos on YouTube. In fact, NPTEL only shares the YouTube links of all the videos. So you can just search my name, Yashvanth L, and you can navigate to 2025 Signals and System playlist. You will have all the lectures available. And the notes also will be available on the, I think there is a separate Excel sheet that NPTEL is sharing with all of you that has a link to notes also. Okay. Um, Please confirm if you're able to see my screen. I am sharing my screen now. Is my notes visible? Okay. Then let's move on. Okay. The next question is as follows. The Fourier series expansion of a real periodic signal with fundamental frequency f naught is given by Gp of t equals sum over n equals minus infinity to plus infinity Cn e power j 2 pi n f naught t. So we had k, right? Instead of k, they are defining with respect to n. That's the only difference, but both are same. Now it's given that C3 is equal to 3 plus J5. What is C minus 3? I think you should be able to guess it right away. Yeah, tell me. See, the only thing you need to, let me give you the clue. It is said real. We have studied this many times. For a real periodic signal, your C minus K is something but the conjugate of CK. Correct. Therefore, C minus 3 is something but C3 conjugate. But given C3 is 3 plus J5, therefore conjugate is 3 minus J5. So the answer is D. Is it clear? It's just one step answer. It's such a simple question. It appeared in GATE 2003. Very simple question. Just you don't even need to write down anything. You just need to, just by looking at the question, you need to tick option D and move on. Okay. The next question is, let h of f denote the frequency response, that is the Fourier transform of the impulse response of a RC low pass filter. So RC means, I think you would have studied in networks, right? Network theory, R means resistance and C stands for capacitance, and you're building a low pass filter using an R and C, resistor capacitor. Then let F1 be the highest frequency such that for f between 0 to f1, your h of f1 divided by h of 0 is at least 0.95. Given the question is, let R equal to 1 kilo ohm and C equal to 1 microfarad. What is F1? Okay, so this knowledge requires a little bit of circuit theory knowledge, because first of all you're given RC low pass filter, but how does RC low pass filter look like? I don't know. First we need to be able to write H of F. So from device theory, what you can show is that an RC low pass filter is essentially this one. That is, what you do is that you give the input at this is your input terminal, and then it passes through a resistor here and a capacitor here. They both are passed like this, and you take the output only at capacitor end. So this output will be a low pass function of input, and the cutoff frequency is decided by the values of R and C. Okay, this you require a bit of circuit theory knowledge, but of course the assumption is that by the time you give gate, I think this is also gate question, maybe I forgot to mention which year. By the time you give gate exam, you will have knowledge from all different courses. So this is a slight um, background you need from circuit theory course. Okay, now I know what is the output. The output H of F. What is H of F? This is now, as far as when you take the output here, it is like C and R are in parallel configuration. Therefore, output is nothing but the whatever is the output C you get from the capacitor divided by the total energy. 1 by j omega C is nothing but the capacitance, if you remember, right? 1 by j omega C. I think it has I forgot the name, some reactance or something like that. That's the impedance seen just through capacitance is nothing but 1 by j omega C. And it's in parallel configuration. Therefore, it is 1 by j omega C divided by 1 by j omega C plus R. Now you simplify this, take LCM. Okay, then you can show that this comes out to be 1 by 1 plus j omega c, or multiply by j omega c on numerator and denominator. This becomes 1 by 1 plus j omega rc. But omega is nothing but 2 pi f. Therefore, h of f is nothing but 1 by j 2 pi f rc. Until now, is it clear? Sorry, I didn't follow. Is it clear? I mean, I didn't follow whether you understood. Is it clear till now? Okay, I guess it is clear. But if not clear, please, this is the right time to ask. Otherwise, I won't know whether it's clear or not. Okay, so h of f is nothing but 1 by 1 plus j 2 pi f rc. Now, h of 0 is what? Put f equal to 0, therefore it's just 1. Now, h of f1. The given question is, what is the value of f1 for which h of f1 divided by h of 0 is at least 0.95? So, h of f1 by h of 0 is anyways 1. Therefore, it is just h of f1 should be at least 0.95. And it's mod, right? Mod is, there's mod. So, h of, it should be mod actually. Okay. When you take mod, then what happens? It's a complex number. Okay, it's a complex number. So, it is same as saying 1 by square root of 1 plus 4 pi square f square r square c square must be at least 0.95. And now put the values of r and c. So this means basically what you can show is that rearrange square on both sides and then rearrange all these terms. You can show that this is same as saying 1 plus 4 pi square f1 square r square c square must be less than or equal to 1.108. Okay, now what you do, put for f1 r and c. Sorry, r is given as 1 kilo ohm and c is given as 1 microfarad. Put these values. You can show that f1 is at most 0.329 by 2 pi into 10 power minus 3, which is nothing but 52.2 hertz. Therefore, the upper frequency, it says the highest frequency, right? Therefore, the highest value of f1, that is f1 is at most less than or equal to 52.2. Therefore, the highest frequency of f1 for which h of f1 by h of 0 is at least 0.95 is 52.2 hertz. Is it clear? Is the solution clear? Hello, is the solution clear? All I'm saying is you put just substitute for R and C. You can show F1 is at less than or equal to 52.2 hertz. Therefore, the value of F1, the highest value of F1, so that H of F1 by H of 0 is at least 0.95 is 52.2 hertz. Is it clear? Hello, no one is replying till now. Can you please confirm if is it clear till now, or you want me to repeat? Okay, so shall I repeat or is it clear? Yeah, no problem, connectivity issue, but shall I repeat or is it clear? Okay, you will go through, no problem. Okay, let's go to the next question. The next question says is, let tau g of f be the group delay function of a given RC low pass filter. Okay, and f naught is equal to 100 hertz. That is the basically what they're asking is the given frequency of operation is 100 hertz. What is tau g of f in milliseconds, expressed in milliseconds? Basically, they're asking what is the group delay. So it's given RC low pass filter. Therefore, just go back to the previous question. We just derived h of omega for the frequency response of an RC low pass filter to be 1 by 1 plus j omega RC. So just take that. H of omega is 1 by 1 plus j omega RC. That is the frequency response of the given filter, RC low pass filter. But for group delay, what you should do? You should find the negative derivative of your phase response. Therefore, you need to find the angle of h of omega. Angle of h of omega, when you divide two numbers, the angle will get subtracted. Therefore, angle of numerator minus angle of 1 plus j omega rc is the angle of h of omega. But angle of 1 is a real number. There is no angle for real number. Therefore, angle of 1 is 0. But angle of 1 plus j omega rc is nothing but tan inverse of omega rc by 1. That is tan inverse of imaginary part by real part. Therefore, the angle of h of omega is nothing but minus tan inverse of omega rc. Therefore, what is your group delay? Is nothing but minus d by d omega of angle of h of omega at omega equal to f. Therefore, you just differentiate minus tan inverse of omega rc. You will get this. Okay. And then you substitute the values of r, c, and f. So basically, r is nothing but given to be, okay, maybe r is from the previous question only. Oh, okay. 6 and 7 are for the same, they basically constitute the same question. Basically, same, so you need to reuse the value from r and c from the previous question in the next question. Put f equal to 100, you will get, it turns out to be 0.717 milliseconds. Simple. In fact, it's not omega equal to f, it will be omega equal to 2 pi f. Okay, is it clear? Yes, is this clear? Okay, I guess it's clear. Let me move on. Okay, next question is interesting question. Okay, question goes as follows. Let x of t and y of t with their respective Fourier transform x of f and y of f be rated as shown below. That is, this is your x of t. That is, it's a triangle signal from -2 to 2 with amplitude 1 at t equal to 0. The peak goes to 1 at t equal to 0 as a function of t. And y of t is something different. It is basically inverted triangle from the base having -2, 0 to 0, 0 and amplitude is -1. These are x of, this is x of t and y of t. Question is, how was y of f related to x of f? That is a question. Okay, we need to express y of f as a function of x of f. You see, all the 4 options are like that. Okay, this is also a gate question, but I maybe forgot to indicate the year. Okay, so that's basically the question. So for this, the key trick is somehow express y of t. What series of operations will you do on x of t so that you will get y of t? If you know the sequence of operations, if you know the sequence of operations that you will do on x of t to get y of t, and then use the properties of Fourier transform to derive the Fourier transform of y of f in terms of x of f. That is all you need to do. Okay, so you see what I'm going to do. This is a given x of t. That is, it takes the value from -2 to +2, and peak is at 1. First operation, what you do, you compress this triangle to only range between -1 and +1, but same peak one. Call that as w of t. Okay, basically this signal became a compressed version in time domain because it's only from -1 to +1, not -2 to 2. In excuse me. In fact, you have compressed by a factor of 2. That is, if you divide by 2, I mean, if you compress by a factor of 2, you get from -2 by 2 -2 to +2 will become -1 to +1. Therefore, can I say that w of t is equal to x of 2t? Is it okay? Is this okay? X of 2t is nothing but w of t because I've exactly compressed by a factor of 2 to get w of t. First of all, is this clear? W of t is equal to x of 2t. Just looking at this x of t to w of t transformation. Yes, can you please confirm? I guess so, because I guess you have some internet connection, but it's okay. Let me move on. Okay, then what I do, I will move this rectangle by 1 unit to the left side. So then what happens? -1 to 1 will become -2 to 0 because -1 -1 because -2, 1 minus 1 is 0. Call that as z of t. Therefore, z of t is nothing but w of t plus 1 because I'm moving to the left. Therefore, I will do t plus 1. So z of t is equal to w of t plus 1. Okay, then what I do is the z of t, I just invert it. Do negative, just invert this triangle becomes this triangle. That is y of t is equal to minus z of t. Okay, you do basically you do z of t inverted minus, you get y of t back. You see why this is exactly what is given in the question. This y of t is same as what we got. Therefore, we have now found a sequence of operations which, if you do to x of t, you will recover back y of t through this intermediate signals w of t and z of t. What are those operations? W of t is equal to x of 2t. In other words, w of f is nothing but 1 by 2 into x of f by 2. This is nothing but scaling operation of Fourier transform. Property of the Fourier transform for time scaling. W of f is equal to 1 by 2 into x of f by 2. Now what I did, z of t I obtained. This moved by 1 unit on the left hand side. Therefore, z of t is equal to w of t plus 1. Or in other words, z of f is something but w of f into e power j 2 pi f. This is something but time shifting property of Fourier transform. But what is w of f? Half into x of f by 2. Therefore, z of f is nothing but half into x of f by 2 into e power j 2 pi f. And finally, y of t is nothing but minus z of t. Therefore, y of f is equal to minus half of x of f by 2 into e power j 2 pi f, which is nothing but option B. Is it clear? Is the solution logic clear? Maybe you can go through the exact details later on in the notes, but is the logic clear? Is the approach clear? Okay, I guess it's clear. Let's move on. The next question is basically as follows. The 3 dB bandwidth of a low pass signal e power minus t into u of t, where u of t is a unit step function, is dash what? I'm asking what is the 3 dB bandwidth? What do you mean by 3 dB bandwidth? The place at which the power exactly, the energy or power becomes exactly half. That is called the 3 dB bandwidth. Okay, so what you need to do, you need to find the Fourier transform of e power minus t into u of t. So what I'm doing here is that I'm just computing the Laplace transform, and then from there I'm computing the Fourier transform. So mod of the Fourier transform should be 1 by root 2. Why? So that when you square it becomes half. The amplitude square represents the energy, right? So therefore energy should be half, and that's what I'm doing. So that means 1 by, if you recall, the e power minus t into u of t has a Laplace transform 1 by s plus 1. Or its Fourier transform will be 1 plus 1 by j omega. So the mod should be equal to 1 by root 2. And that value of omega for which this becomes 1 by root 2 will correspond to the 3 dB bandwidth. Okay. In fact, of course, you should express that in terms of f also. Frequency. Omega is the angular frequency. Therefore, all you need to do is just do 1 by square root of 1 plus omega square, which is because of taking mod, which should be equal to 1 by root 2. Or you can show that omega equal to 1 radians. Or since omega is equal to 2 pi f, your f should be 1 by 2 pi hertz. Therefore, it is option A. Okay. So that this is the 3 dB bandwidth of the low pass signal e power minus t into u of t. Okay, I guess some of you have left and rejoined again for connectivity issue. I can just quickly repeat. So basically the question is, what is the 3 dB bandwidth of the low pass signal e power minus t into u of t, where u of t is a unit step function. So basically 3 dB bandwidth means what? Exactly the bandwidth, the frequency at which the power or the energy becomes exactly half. Okay, that is what I do. I call for e power minus t into u of t has a Laplace transform 1 by s plus 1. And put s is equal to j omega, because you need to get Fourier transform. Fourier frequency response means Fourier transform. So put at s equal to j omega, the magnitude of this number, the response should be equal to 1 by root 2. Why root 2? Because if you square on both sides, it becomes half, because the energy is equal to half. That determines the 3 dB bandwidth. Therefore, 1 by mod of s plus 1 and put s equal to j omega is nothing but 1 by root of 1 plus omega square. Is it clear? Just put s is equal to j omega and take the mod. Therefore, you get 1 by root of 1 plus omega square, and that equals 1 by root 2. If you solve for omega, that becomes 1 radian. Or they're asking what is the bandwidth, means frequency. Omega is an angular frequency. So frequency is nothing but omega equal to 2 pi f, and put omega equal to 1. Therefore, f is equal to 1 by 2 pi hertz. Therefore, answer is option A. Is it clear? Okay. Interesting question, and yet another interesting question. The question is as follows. A 5-point sequence x of n. Okay, so x of n is just you have 5 points. It's given as x of minus 3 is 1, x of minus 2 is 1, x of minus 1 is 0, x of 0 is 5, and x of 1 is 1. So these are the 5 values of the signal. But then what's it's given that x of omega be the DTFT of x of n. That is discrete time Fourier transform. The question is, what is integral minus pi to plus pi x of omega d omega? Okay, it turns out to look difficult, but it's very easy. Very easy. Okay, a very simple trick. What the trick is as follows. What is the recall that inverse discrete time Fourier transform was given by x of n equal to 1 by 2 pi integral minus pi to pi x of omega e power j omega n d omega. Now just put n equal to 0. Then that means x of 0 equal to 1 by 2 pi integral minus pi to pi x of omega d omega, because if you put n equal to 0, it becomes e power 0, which is 1. Now you see, what do you see? That means you put this 1 by 2 pi to the left hand side. So what you have, integral minus pi to pi x of omega d omega is 2 pi into x of 0. But you see, left hand side is exactly what is asked in the question. What is the value of integral minus pi to pi x of omega d omega? Therefore, the answer is just 2 pi into x of 0. And x of 0 is given to be 5. Therefore, it's 2 pi into 5, which is 10 pi. Is the solution clear? Okay, great. Okay, next question is as follows. Second interesting question. Just see, all of what we did till now, it's only simple manipulation of the formulas and properties. There's nothing like you need to do so much calculation to find the answer. Okay, that's how gate questions are. Okay, so practice a lot of questions. You will not only understand signal systems and much better, but you will also know many more new things. Okay. Okay. Next question. The first 5 points of the 8-point DFT. That means you are taking 8 points for a DFT, but the first 5 points are given to be 5, 1 minus J3, 0, 3 minus J4, and 3 plus J4. Note that it gives a real valued sequence. That is, the time domain signal is real valued, but the DFT of the sequence is first 5 points of the DFT is 5, 1 minus J3, 0, 3 minus J4, and 3 plus J4. So the question is, what are the last 2 points of the DFT? Okay, they're given 5 points. What is x of 6 and x of 7? Why? Because 8 point means it will start at x of 0 and it will go on till x of 7. Therefore, what is the value of x of 6 and x of 7? They're asking this question. Okay, they have given x of 0 to be 5. So that's what. Yes, is there a question? Sorry, I didn't understand. Okay, let's move on. The key aspect to again note is that it's a real valued sequence, right? It means the time domain sequence real valued. So recall that for a real valued sequence, x of minus k is nothing but xk conjugate. But for in the context of DFT, what we saw is minus k means it's not just minus k, it's minus k mod n, where n is the number of points with which you take the DFT. Therefore, x of minus k mod n is same as x of n minus k. Do you agree? That's because I can always, this minus k mod n is same as k minus k plus n mod n. Both will be same because minus k is a negative number. So add n to it, it will be a number between 0 and capital N. Okay, so minus k mod n is same as minus k plus n mod n. Therefore, x of minus k mod n is same as x of n minus k. And there's a conjugation, therefore you can always say x of k is equal to x conjugate of n minus k. That's all. If you have recognized this property, then you know to solve the question. So in this case, n is equal to 8 because I have given you're taking 8-point DFT. Therefore, x of k is equal to x conjugate of 8 minus k. Now they're asking what are the last 2 points. Okay, therefore, what are the, so in general, is x of 0, x of 1, and so on till x of 6 and x of 7 because it's 8-point DFT. They're asking what are these last 2 points. Therefore, x of 6 is nothing but put k equal to 6. That means it is same as x conjugate of 8 minus 6 or x conjugate of 2. But we know x conjugate of 2. This is x of 0, x of 1, x of 2. So x of 2 is nothing but 0. Therefore, 0 conjugate is nothing but 0. Similarly, x of 7 is nothing but x conjugate of 8 minus 7, which is x conjugate of 1. The first point is x of 0, second point is 1 minus j3. That means conjugate of 1 minus j3 is nothing but 1 plus j3. Therefore, the last 2 points are 0 and 1 plus j3. See, this option B matches. So, the last 2 points are 0 and 1 plus j3. This is the question from 2011 GATE exam. Is the solution clear? Okay, very good. This is the last but not the least question for today. The question is as follows. A causal LTI system is described by the difference equation, which means a discrete time LTI system. Y 2 times y of n equal to alpha yn minus 2 minus 2 times xn plus beta times x of n minus 1. Question is, the system is stable only if, which of these options will ensure that the system is stable? So again, a GATE 2004 question. Okay, so always what is the criteria for stability? That the unit circle should be included in the ROC. That's all. Okay, so compute the from the given difference equation, compute the system function and check whether the ROC of the system function contains unit circle. For what values of alpha and beta will the ROC contain the unit circle? That from that you can choose one of these 4 options. That's what we're going to do. So 2 times y of n equal to alpha times y of n minus 2 minus 2 times x of n plus beta times x of n minus 1. Now take z transforms on both sides. So that is 2yn will become 2 times y of z. Alpha times yn minus 2 becomes alpha times z power minus 2 into y of z. 2x of n becomes 2x of z, and beta times x of n minus 1 becomes beta times z inverse of x of z. Now collect all y of z common and x of z common, and you get get y of z by x of z. What it comes out to be beta z inverse minus 2 divided by z minus alpha z power minus 2, which is nothing but a system function h of z. Now, basically, for the system to be stable, ROC should contain unit circle. Now, my claim is that ROC, so h of z, ROC is basically the something which is the exterior part of the unit circle, exterior part of some circle. Okay. Now tell me why is it exterior part? Can anyone tell me why am I saying that the ROC should be exterior part of circle? See, in particular, this z minus alpha z power minus 2 equal to 0. You will get some number, right? That is the pole. In fact, at that the unit a circle with that number as a radius is the defining ROC, and I'm saying that outside that circle is the region of convergence. Can anyone tell me why am I making that it's the exterior part of some unit circle? Yes. Can you guess why am I saying that it should be exterior part? Okay, let me give you the answer. See the first term in the question. It says a causal LTI system. That means if the system has to be causal, the ROC should be an exterior part of some circle. That's why I'm saying it should be an exterior part of the some circle. Now is it clear why I'm saying the ROC is again exterior part of the circle? Yeah, correct. Fine. Therefore, ROC is exterior part. Therefore, now, since the system is causal, ROC is exterior part of the circle. Now, in addition, I'm asking when will it be stable? For that, the poles should be within the unit circle. Why? Only if the pole is within the unit circle, From that point onwards, ROC will start. There, in that case, your unit circle will be included in the ROC. Your pole should be within the unit circle, because that is the value of the pole, the rate, basically the circle with the radius equal to the pole value, magnitude of the pole value, will determine the ROC value, from where the ROC will start. And if the ROC has to contain a unit circle, the magnitude of the pole should be less than 1. It should be within the unit circle. Right? For that, first let's find the pole. That is, what is the pole for which the denominator of h of z equal to 0? That is z minus alpha z power minus 2 equal to 0. You can show that the value of pole is equal to square root of alpha by 2. And this pole has to be less than 1. Only then the ROC will be something like this. See, this is your unit circle. This is mod z equal to 1. And your ROC will be something like this. And this value is basically alpha. This radius is basically square root of alpha by 2 or something. Now this guy has to be less than 1. Only then the ROC will contain this unit circle mod z equal to 1. Therefore, if square root of alpha by 2 is less than 1, or alpha is less than 2. So we didn't have any condition on beta. Only we had condition on alpha. Therefore, the option is mod alpha less than 2, any value of beta. Is it clear? Okay. Very good. So I think that is basically the end of the today's session also. So are there any questions? Okay. If there are no more questions, I think that's the end of today's class. Okay, so this was the last session for this course. Thank you so much for all of you for having patiently sat through my sessions, and all the best for your exams also. Let's hope we meet somewhere in some other course in future. Okay. Yeah, if you have any feedback, uh, be it both positive or negative, please do fill up the form. It will be highly helpful. Okay, then. Thank you. Yeah.